Okay, so last thing we did yesterday, we talked about how to find that p-value, that probability value from our table, if it's a left tail, right tail, or two-tail test, and then we left off finding the p-value in our calculator. Okay, so today, this slide is really just review from chapter 5 is when we did this, so nothing new here. But this is how we found the z-score in the past. So we did our x-bar, so our sample mean, minus our population mean divided by our standard deviation of our population over the square root n. When we do hypothesis tests, the population mean here is going to be what is in our hypothesis. Okay, so it's what we're hypothesizing about. So if our hypothesis is that the mean is greater than 62 minutes, 62 would be that population mean. Okay. All right. So on the next slide are all of the steps we're going to be doing. None of this is new. Just putting it together is, I guess, the new piece today. So we want to make sure at the beginning of all of these tests today that we know the population standard deviation. When we get to the next section, we won't know the population standard deviation, and that's going to be the difference in the two lessons. So it's just something we want to get in the habit of checking. We also want to make sure that one of those two conditions we talked about before is met, whether either the population is normally distributed or our sample size is bigger than 30. Then we're going to state our claim, and we're going to write the null and alternative hypothesis. So one of those will be the claim. The other will not. Remember, the null hypothesis is always the one that contains the sign of equality. The alternative does not. Then we're going to either specify a level of significance. A lot of times you'll just be given that one. Then we're going to find our z-score like we've practiced in the past. Find the area that corresponds to the z-score on our chart. Okay, so that's going to be helping us then get the p-value like we practiced yesterday. So if it's a left tail, we use the value on our chart. If it's a right tail, we added this on there yesterday. It's 1 minus the area to the left. And if it's a two-tail test, we take the area in one of the two tails and just double it. Then, like yesterday, we're going to compare p to alpha. If p is less than or equal to alpha, we reject. If p is greater than alpha, we do not reject or fail to reject. And then we interpret the decision, which was part of the video that you guys watched on Monday. All right, so let's put them together and do all the steps now. Let's complete a hypothesis test finally. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times with sample mean of 12.9 seconds. Assume the population standard deviation is 0.19 seconds. Is there enough evidence to support the claim at a level of significance of 0.01? And we're going to use p-values. Now, the reason it says use p-values at the end is tomorrow we're going to do another type of hypothesis testing that's similar, but it uses critical regions, rejection regions they're called. So you'll have both in this lesson, which is why it's telling us to use that p-value. All right, I'm going to number this the same as those numbers are on your paper, just so you can follow along with it. All right, so first thing we want to do is verify that we know the population standard deviation. What is our population standard deviation? You have to talk this morning. We're going to do that. Okay. Population standard deviation is 0.19. Okay. And then we want to verify that we're either normally distributed or sample size bigger than 30. Is one of those true? Which one? Sample size here is 32. So that meets our conditions. Okay, that's all we have to do for the first step. Second step is we're going to state the null hypothesis, and we can state it mathematically. You can state it in words also. You might have to do that and make a selection with that in Math Excel, but usually we state it mathematically. And then label which is the claim. Okay, so we want to start with the claim that's being made and work backwards from there. So a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. Okay, so the claim in this whole section, all of the claims are going to be about a mean. The mean is less than 13 seconds. Is that going to be a null or alternative hypothesis? It's going to be alternative because it is not equal to. And again, that is also my claim. Okay. So then the null hypothesis is the complement of that. If I'm not less than, I'm greater than or equal to. Okay. Any questions on that step? Writing those. Okay, next up, third step on here was level of significance. They gave us that, 0.01, easy enough. Number 4, standardized test statistic. Okay, so for this, we need x bar minus mean over standard deviation divided by the square root of n. Okay, so a couple of these we've labeled already. The mean, population mean we have is 13. That's inside our hypothesis there. The population standard deviation was 0.19. We have that guy. We have n labeled already. The only other thing we don't have labeled is the sample mean, x bar, which you can get up here, is 12.9. Okay, so we're just going to fill all that in. 12.9 sample minus population, 13, over 0.19 divided by square root of n, square root of 32. If you're going to type all this in your calculator, I would recommend using the alpha y equals a couple times to set up fractions, or at least put that denominator in parentheses. If it's a z-score, remember we're going to round to 2 decimal places because that's what my chart goes to. Okay, so 12.9 minus 13 gives me a negative 0.1 on top. On the bottom, 0.19 divided by square root of 32 gives me about 0.034. And then if I divide that answer in to 2 decimal places, negative 2.98. Okay. Good there? All right, next up, step 5. Let's go ahead and find our area that corresponds, and then step 6, I think these kind of go together. We're going to find the p-value that goes with it. All right, so negative 2.98. Let's see what we got. I got 0.0014 is the area that I find out of my chart. Can you tell me if this is, we need to know if it's a left tail, a right tail, or a two-tail test? Left tail, right tail, or two-tail test? Yes, so it's a left tail test. And we could have labeled that earlier. As soon as you know what your alternative hypothesis is, that tells you what the tail is. So because it's less than there, that's how we know it's a left tail. Because it's a left tail, we don't have to do anything with that area. Our p-value is also 0.0014. Okay, if it's a right tail, we do 1 minus. If it's a two tail, we find one of the tails and double it. Okay. Step 7 now. We're going to compare that to our alpha. P compared to alpha. And what was our alpha? 0.01, right? Okay, so P is 0.0014, alpha 0.01. So in this case, my P is less than my alpha. If it's less than, what does that tell me to do? We need to either make a decision of reject or do not reject. Reject. Based on that. Okay. All right. At the end, then, we summarize, and this is important. The lesson on Monday that you guys watched the video of, there was a decision chart that had to do with what the claim is, and whether it's the null or the alternative, and then whether your decision was to reject or not reject, and then how you kind of phrase or summarize the statement at the end. If you reject, we say there is enough evidence. If you do not reject, we say there is not enough evidence, okay? But the goal usually when we are doing something as a researcher is reject usually something that's bad. We like to reject something. That means we have enough evidence for something to happen. So rejecting is good in statistics. There is enough evidence to if your claim is the alternative, we say support the claim. Because what's happening, remember, is when we reject, we are rejecting always the decision that's being made is on the null hypothesis. So we're saying we have enough information to say that greater than or equal to, we're rejecting that. That's not true. So we have enough information then to say if this one's not true, we can support this one instead. Okay? So when you guys do those in Math Excel, those are usually like drop-down options that you're going to pick from: is not, support, reject, that sort of thing. All right? Make sense? Any questions? Putting it all together. Okay. Let's do another one. According to a study of U.S. homes that use heating equipment, the mean indoor temperature at night during winter is 68.3 degrees Fahrenheit. You think this information is incorrect? You randomly select 25 U.S. homes that use heating equipment in the winter and find that the mean indoor temperature at night is 67.2 degrees. From past studies, the population standard deviation is known to be 3.5 degrees Fahrenheit, and the population is normally distributed. If is there enough evidence to support your claim at a level of significance of 0.05? Okay, I'm not going to number everything this time around. I'm just going to start kind of labeling things that I know. So just kind of running through what everything represents. According to a U.S. study, the mean indoor temperature, the claim that's being made is, the claim is 68.3 degrees. So that's going to be, and we'll write the claim in a little bit here, my population mean value. Okay, that's the value that we're testing. You randomly select 25 U.S. homes. That's my N. And find that the mean temperature of those homes was 67.2 degrees. So my sample mean is 67.2. We know the population standard deviation is 3.5. And we are also told that the population is normally distributed. So I automatically know now that my population is normally distributed. I know the population standard deviation. I've met all those conditions at the start there. Level of significance for this problem is 0.05. Okay, so that's all the information we can pull out of that. All right, we've met our conditions. Next thing, let's write our null and alternative hypothesis and label, which is the claim. Okay, so reading that first statement one more time, it says, according to a study of U.S. homes that use heating equipment, the mean indoor temperature at night during winter is 68.3 degrees. So this is going to be an equal to, not equal to situation. The mean is 68.3. So that is my claim because it's equal to, I know it's my null hypothesis, which means what's the alternative going to be then? That the mean is not equal to 68.3. Okay, next I need to find my z-score. Okay, so again, z is x bar minus mean divided by standard deviation over square root of n. And we've labeled all those things. Let's fill them in. 67.2 minus 68.3, always the sample minus the population on the top there. Standard deviation, 3.5 over the square root of n square root of 25. And remember, we're going to round to 2 decimal places. 67.2 minus 68.3 is negative 1.1 on the top. On the bottom, 3.1 over square root of 25, or just 5, gives me 0.7. If I divide those, I get negative 1.57. Okay, can you tell me if this is a left tail, right tail, or two-tail test? Left tail, right tail, or two-tail? Yep, as soon as I want to know what my tail is, I look at my alternative hypothesis. The not equal to situation creates two tails. This is where it could be helpful to kind of sketch out what we have here. So my z value is a negative value, which means it's on the left side. So from my chart, I can just go ahead and get that tail. If your z value was on the right side, you would, from the chart, have to do 1 minus this value to get what's in the right tail. So sometimes there's an extra step in this two-tail test. if your z-value is positive. Okay, so negative 1.57, what do we have here? 0.0582 is my area. So then my p-value, that's that area there if I shade it in the picture, is double that, 2 times 0.0582. I get 0.1164. 0.1164 is my p. Okay, compare p to alpha. P is 0.1164, and what was our alpha here? 0.05. Okay, so how does P compare? P is greater than, less than. We know this, greater than. Okay, if it's greater than, what do I do? Reject or not reject? Okay, do not reject, or you can say fail to reject. And let's get in the habit of just saying what we're not rejecting or rejecting. We are not rejecting the null hypothesis is always what the decision being made on. No matter what the claim is, the decision is always on the null hypothesis. Okay, so we made our decision not to reject, and now we summarize. So if we do not reject, we say there is not enough evidence to blank the claim. And this is where you have two choices. It's either reject or support, and it all has to do with what your claim was. In the last problem, our claim was the alternative, so we use the word support. In this problem, our claim is the null, so we use the word reject. We do not have enough evidence to reject the claim. Any questions? All right, third and final problem for today is yours to try, and we're going to put answers up on the board. And then when you get to the Math Excel, you might have seen it already, it is only 3 questions. Now they're longer because they're like this, but there's 3 hypothesis tests that you guys can then work on at the end of the period, okay? All right, I'll give you a few minutes and I'll let you know what you're in charge of putting up on the board. Maybe if everybody's on the correct time. Okay. You are going to put up whatever the population is. Sample mean. N. Population standard deviation. Kara, level of significance. Victoria, null hypothesis. Ash, alternative hypothesis. Kara, label which is the claim. Ria, which type of test is left tail, right tail, two tail? No, okay. I want you to fill in the z-score formula, and I want you to simplify the z-score formula. Okay. I want you to find the area on the chart Just whatever number you find on the thing, that's it. I want you to find the p-value. Okay. I want you to fill in the circle between the p and the alpha, less than, greater than. Okay. I want you to write, is it reject or not reject hypothesis? I want you to write the summary statement. And okay. Look, everybody got something. Look how well that worked. All right.